find the length of AB. And in some of the homework previous to this, some of you came and said, like, why do they have these letters? Well, because in the real world, there's not always going to be a nice X pointing to the thing you have to find. In the real world, sometimes you have to figure out what to find. So we use letters to name angles and triangles. What does it mean when it says AB and it just sticks those two letters together? It means from A to B. So let's put an X there. We're talking about A to B. That's the side we need to find. Why are these called double triangle questions? Two triangles. Well, the problem is if we just look at the bottom one, so ignore everything else in the question, and I said find X, what's the problem?
We didn't get a value for...
Do we have enough information? No, that's the double angled or double triangle questions. As you go to use your triangle to find what you define, you're going to be like, oh, I don't have enough. I need something else. That's what the purpose of this triangle is you're always going to be able to find something in the other triangle that's going to allow you to find something in the first triangle. So generally, it's when they share something. What side do they share? BD. So what we're going to do is first find BD in the upper triangle and then use BD to find what we want. So the method is, number one, find a value in, and I'm going to put in quotes, the other triangle. So not the one that we actually need to find, but it's usually the other triangle. And I'm going to put a semicolon. Usually it's some kind of shared value. Could be a shared side, shared angle, shared side or angle. Step number two, use that value. To find the value asked in the question. To find the value asked in the question. So they're just typically two-steppers. You got to use one triangle to find something, then use that something to find what you actually want to know. Visual people, sometimes it's helpful to cover half the diagram because then your brain doesn't see as much stuff and it tends not to get as confused. If this doesn't work for you, don't do it. Okay, so I want to find the shared side, so let's name it. Well, it's going to be opposite the right angle, so it's called H. Opposite the given angle is O. Step number two, pick a formula, SOHCAHTOA. Sine, so we have, where am I going to put this over here? Sine theta equals O over H. I'm just going to use a sticky to cover. Do we have an angle? Okay. Do we have O? Do we have H? Nope, so I'm just going to leave it as H. You can put it in a different variable if you want. I'm just going to leave it. H is on the bottom. H is on the bottom. H is on the bottom. What's the shortcut to isolating H when it's on the bottom? Swap it. Again, if you want to do that in two steps, you want to multiply by H, then divide by sine 26, that's fine. I'm just going to do the switch. I love the sound of the covers coming off the calculator. Makes me happy. Value? 9.6 is the offer. Confirm. Okay, so I'm just going to add that to our diagram. Now we're going to use the triangle in the question with our x, and we're just going to do the exact same process. What is the 9.6? What side? H. What side is x? A. A-H. A and H. A and H. Cosine? Ooh, thank you. Do we have an angle? $47. Do we have A? So you can leave it as A, you can put in X because we called it X, either one. Do we have H? 9.6. How do I get rid of a division by 9.6? Multiply it up to the other side. Offer of 6.5. Confirm. There we go. So double triangles are just like two questions in one. Same 5 steps we've been doing all unit. Have the steps changed yet? Have there been any exceptions? That's the joy of trig. Same 5 steps every single time. Okay, number 2. Find the length of ST. Find the length of XT. So I always start by putting a variable wherever they're asking us what we need. We don't have enough information in the triangle on the left, so that means we have to go to the triangle on the right. Probably we're going to have to find a shared side. So what's the shared side of the triangle? PT, TP, doesn't matter the order. Okay, so again, visual people, sometimes it's helpful just to cover and just look at the one triangle. Okay, we want to find TP, so let's label it. Is it O, A, or H? It's O. 219, O, A, or H? H. O. 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 Sine. Finish that one off and get me sine, or get me H in this case, O in this case. Offer of 109.5, looking for confirmation. Yeah. Okay, so let's label that 109.5. Okay, so in the triangle on the left, 109.5 is which side? Still O. Sometimes it won't still be O. Sometimes it could be A, so you just have to double check. This is still O. What's the X? H. O and H. O and H. O and H. Sine of 50 equals 109.5 over X. If you want to use the quick way, how do we isolate X? Switch it. Again, if your brain wants to do it in 2 steps, that's fine as well. Offer of 142.9. There we go. Show me how you're feeling so far on double triangles. Good. We're going into the word problems. If you would like to push your desk next to a friend like we did yesterday, do that now. If you don't, don't. Whew, there is a lot of words in this one. This might be your super scary if it was a homework question. Just read to read. Don't overthink. Just put the context in your head. No stressing. Just read. Okay, let's read to understand. So the first part of the sentence above the diagram, what's important? Yep. Okay, the first sentence under the diagram. Okay, the last sentence. And I'm just going to highlight the question word. Okay, let's just check we have all the key information. So close your eyes or look up, just look away and just listen to me. Ramp, longer part of the ramp, 8 meters. Shorter part, 1.5 meters. Angle of inclination of the smaller portion, 60 degrees. What angle of inclination, longer portion? Is that enough to answer the question? Okay, let's go to. Where do you want to start? So if this was a test question or an exam question, what's the first thing you would do after you've highlighted and you picked out the key? Probably label the diagram. Where would you like the 8 to go? Okay, so is it the bottom or is it the actual ramp? It's the actual ramp because it says of the ramp. If it wanted the bottom, it would say the base of the ramp, the bottom of a ramp, the horizontal distance of the ramp. Where would you like the 1.5 to go? The shorter part. How do I know that it's the diagonal line or the hypotenuse and not the bottom? Same as before, of the ramp. Okay, it doesn't say bottom, base, or horizontal distance. Angle of inclination. What's an angle of inclination? So many points. Show me a horizontal line using your arm. Okay, perfect. So we're going from the bottom of the smaller part, and the angle that's formed there has to be 60. How do I know it's there and it's not the one that's at the top? Well, this is still in the smaller portion, but how do I know it's not the one at the top? Not horizontal. How do I know it's not the one way over here on the right? Because it says the smaller. Okay, and we can put in our right angles because we know those are both going to be right angles. Okay, let's put an x somewhere or a variable of some sort. What are we looking for? Angle of inclination of the bigger. Because it's an angle, what generally should we use for a variable? We don't usually use x because we like the Greeks, right? They made feta cheese. That's exciting. Okay, double triangle question usually means you can't use the triangle where your variable is. So usually we have to go to the other one. You typically want to find something that's a shared value. What side is shared by these two? The O. What's the 1.5? You and your partner, find me O. That's fine. You got someone there to help you.
Ms. Roberts, please contact the office. Ms. Roberts.
Offer for O? 1.3? But that's so small. Does that value make sense if it's so small? Yeah, well, the hypotenuse is also small. So remember when you get your answer, you can always kind of think about it logically. If this is 1.5, Yeah, it's got to be slightly smaller. It's not going to be a number like 47 or 75. Okay, are we done? That's it? Got an answer? 1.5, 1.3? No, what? No, why aren't we done? Oh, because we've actually got another side of the triangle, or another side of the diagram, which is a triangle. Okay, you and your partner, find me theta. So just remember, part of my job is not only to teach you this math, but teach you how to be mathematicians, because it's this group that's going to go on and be our engineers and our architects and our doctors and all our great scientists. So please do not call this sign with the little negative one thingy. Not its name. Let's use its name. What's it called? Inverse sign. Good job. Somebody have theta for me. Confirm 9.4? Units, because it's a word problem. I heard somebody say it. Degrees. Number 4, I don't want you to do anything yet. I just want you to talk. So if you've already got a partner, great. If you chose to work alone, great. Just turn to someone. Just talk about how you would do this question. So what would you find first? What would you use to find when you just talk about it for a couple minutes? Okay, so let's talk as the large group. Now this one, until you've seen one like it, it can be a little confusing. And so the problem with this one is we're looking for the length of BC. And so you know we don't have enough in that triangle, so you're going to go to the other triangle. Did you talk about finding the hypotenuse? Yeah, that's a normal one because it's the shared side, so you're probably going to find the hypotenuse. The problem with that is once you have the hypotenuse, I want you to look at the triangle that's left. It's not a right triangle. So can we therefore then use that hypotenuse to find theta in this question? No. Next year in grade 11, we'll show you how to deal with non-right triangles, but for now you don't know. So if you follow the normal kind of logical conclusion here is find the hypotenuse, then you're going to get stuck. So there's got to be a different way to do it. So this one, for the visual people, is really easy. For not visual, you have to kind of think about this a little bit. There are two triangles, but we're not going to use the left and right side. We're going to use the smaller triangle, which I'm going to call A to C to D, so triangle ACD. Where's a second triangle? A to B to D. Do you see that I have two right angle triangles there? So I have a big triangle here, and I have a big triangle here. Now for non-visual people, sometimes it's helpful if we draw them separately. So I'm going to take that big triangle and make them slightly smaller for space reasons. So there's ABD. And just beside it, I'm going to take the other guy and call him ACD. So if your brain's getting confused, just split the diagram into two pieces. Is it going to be helpful now to find this AC or find the hypotenuse? No, because this hypotenuse isn't a line in the big triangle. So until you've seen one like this, your kind of gut reaction isn't going to work. You're going to get stuck partway through. What can we do if we can't use this hypotenuse here? Well, if I look at the big triangle, I can find from B to D. I could find that length of the bottom side. And if I look at the small triangle, I could find the length of C to D. So that's finding this whole length here, and then finding this half here. How is that going to help me find BC? Because then we can subtract. So if I can find B to D, and I can find C to D, how do I find B to C? Subtract. So step 1, you're going to use the big triangle to find BD. Step 2, you're going to use the little triangle to find CD. And step 3, subtract. Give you a couple minutes with your partner. Or by yourself. Does somebody have a value for BD? Sorry, a little bit louder.
22.4.
Can somebody confirm? Okay, CD? 6.2? 6. Oh, that's a 5. So I'm just looking for the second triangle. 15.5. That sounded confirmed. Okay, how do I find BC? Subtract them. And this was the 6.9? How are we feeling so far in double triangles? Good. Again, this is one until you've seen it, it's kind of hard to figure out. I think you're ready for 5 with your partner. I think you can do it. Text. Okay, you probably got bored now. If this is a book, you would have shut it. So now let's go back, okay? Nicole works in an office building downtown. Do we care who? Do we care where? Do we care what? No. Maybe building. Maybe. Second sentence. Do we care she was bored? Do we care really what's happening? Not really. Okay, building next door. The next sentence? Yep, it's even in italics. Always know if something in italics is important.
41 degrees.
Maybe something more in there you might want.
Top of
Yeah, top of the next building. Okay, next sentence. It's even bolded. Angle of depression. Base 54. And okay, so let's add all this to the diagram. We know the distance between 54. Thank you, 56. We know she looks up to the top and down to the bottom. And the only thing we need to draw in there as well is the imaginary horizontal in order to get those two angles. Okay, so angle of inclination, 41. Angle of depression, 54. Whoa, that's the first time we're talking angle of depression. So I've marked it there for you. Give me a definition. What's an angle of depression? So it starts from the horizontal. Angle of inclination we've used a few times. It goes up. Angle of depression goes down. What happens if somebody's depressed? They're sad. They're down. Well, this 56 I chose to go at the bottom, but does it matter where I put it, or is the distance between the two buildings always the same? Always the same. So actually, I'm going to add it on this horizontal, and that way it becomes part of our triangles. Okay, part A, what are we trying to find? Her height. So her height to the ground. Well, that's not even part of our triangles. Well, again, we just need to use the fact that her height on this building is going to be the same as her height over here. Really, it doesn't matter the distance. So this is what we're trying to find in the first question. Because if you look at the diagram, it's going to be the same whether it's in the triangle or not in the triangle. So again, just look at this one little triangle. What is that x going to be? Which side? O. What is the 56 going to be? A, so O and A. Tan. Tan of 54 is x over 56. What do I do with that 56? multiply them up. $77? Even? Confirm, that sounds confirmed? Okay, so let's add that to our diagram, 77. How do we do B?
Find the height of the building.
Yeah, so how do we find the height of the neighboring building?
We find the angles given and find the opposite.
So we can find this side of the second triangle and then go to find me the height of the neighboring building.